So now let's start with the module. The first topic we're gonna be studying about the Nexus. Okay. Talking about the Nexus, let's hit certain terminologies as of now. Once we understood this terminology, and then we'll be moving ahead with the core of Nexus, that how we gonna understood what are the different models, what are the different modules inside that, and the different labs and the design section. Okay. So first of all, let's hit the terminology. Basic one. What is the meaning of Nexus? Like, I'm not talking about with respect to Cisco, obviously not. Simple meaning of Nexus is nothing but interconnection. Okay. Or connecting two devices, or connecting two people, connecting two person, connecting two things, or two or multiple things is nothing but your Nexus. Simple as that. No rocket science. Okay. Now, the same meaning somehow came back into the world of Cisco. So Cisco introduced a series of switches. Now you have, right, the Cisco XC series, you have the XR series, you have the Catalyst series. Similarly, Cisco presented a series of switches for the data centers where the throughput value is high, where the traffic is huge. Okay, where the consumption of the traffic is huge. For those target to be accomplished in the world, Cisco came up with a terminology and a concept and a series of product called as Cisco Nexus switches. Okay. Now, what are the different models? We'll be going into the detail with each and every aspect. Don't worry about that. Okay. Now, second word, if I may ask, like in one word or in one line, if you can answer, what is the meaning of data center? What are you going to tell? What is a data center? Simple. We'll start it from the scratch.
Combination of all the devices.
Sorry, sir. Come up again.
Servers. Combination of servers and all the data, like
Okay. Cool. 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 Hub location. All apps are hosted in the servers. Different answers. So basically, if we don't include any technical things, and okay, little bit technical, I'll say. So we have a building, right? In that particular building or any of the location, what we have the routers, we have the switches, we have the firewalls, we have the different devices. So first of all, we require a space, a building. Then after that, we require a high amount of power supply. Once the power supply is there, we are all good to go with the different networking devices, right? On those particular networking devices, we'll be having the, or will be hosting the applications. Okay. And at the end, there will be certain end users who gonna access those particular applications. And this is nothing but eventually, if we club all the words together, this is nothing but a data center, DC, simple as that. Okay. A dedicated space within a building, having different set of networking devices, including routers, firewall, load balancers, anything, any networking device. Okay. What are the different components? So what we need the high compute resources inside your data center, right? Compute resources. Apart from that, what else we need? We need the networking devices. Without that, nothing gonna happen. We need the great amount of power supply units, PSUs. Okay. PSU not with respect to the device, but with respect to that building. We need a high voltage, high supply. Apart from that, we require the storage devices. It can be a NAS device, can be a NAT device. There are multiple types of storage devices are there. We also require one thing to host that particular data center onto the world of internet. What we require, like how today we are using the maximum things. One word, the whole concept. Virtual, right? Virtualization. So data center today gives us the capability for doing the virtualization segment. Without this, nothing can be done. Like you are accessing today Azure, you are accessing today AWS, right? If tomorrow you want to learn or you want any guidance as per AWS also, you can Ping to me, guys. CCI security, CCI data center, AWS, bug bounty hunting, ethical hacking, basically, penetration testing. So I'm into these kind of things. You can ping me if you want any kind of references or any guide for these. Okay. So this is my nutshell. And now, on top of that, I'm a bachelor right now, so I'll be able to give answers to your question. Maybe. Okay. So coming back. So we require these components in order to build up a data center. That is being completed. Nexus, the meaning of that word, interconnection, multiple devices, multiple people, multiple things, nothing but interconnecting. So now in order to interconnect multiple devices inside one data center, which we can call as a intra DC, okay, or between two different data centers, we require a set of switches, we require a set of devices that can eventually come up with a solution or that can provide the huge amount of throughput. It's not easy to connect two different data centers which are located at two different geolocations. You need certain things, certain technology, certain protocols, but those particular protocols, apart from that, you also require high amount of throughput values. You want that your switch can access or is capable of accessing, let's suppose, 400 gig of data or 1 Tbps or 100 gigs or 10 gig. You want that capabilities. Those particular capabilities are being given by the Nexus switches. So that's why these are being used at the core of the data center, even at the distribution level. Okay. So I hope being into EI, you already are aware of the three-tier architecture of core, distribution, and the access. Access layer is what? Nothing but connecting to the end devices, like your laptops, like your desktop, host devices, your mobile phone, not mobile phone, IP phone, basically. Apart from that, all other devices which can be getting connected are nothing but your end host, end devices. So that comes in your access layer. At the distribution layer, you have multiple protocols, ports and protocols, which are being running layer 2, layer 3. Okay. These are basically inside a LAN network, inside a WAN network, all your distribution switches comes into the picture. But at the core, if I talk about, okay, that is nothing but that is a complete backbone, what you require. Okay. That gonna handle the major data chunk that gonna be responsible in order to send the data onto multiple data centers, inter both. Okay. So that is nothing but your backbone. So for that, you require a huge switch, which is capable of having a great amount of traffic, mainly just to pass the traffic into other data centers. Clear till now, everyone? I hope the lecture is going smooth. Yes, no. So we'll be keeping this chat room a little talkative. Okay. You guys can drop any amount of messages over here. Not a problem. It's just like we should be talking to each other. It should be a normal basic bore lecture, because I also get bored then eventually. Now, so now coming to the next point. What else? So today let's start with your very basics of the Nexus. Okay. In the Nexus, there are different families which are available, different families of the switches. There are Nexus 9000, there are Nexus 7000, there are Nexus 5000, which are currently working on in the production, I would say. And then we have the Nexus 2000 devices. We'll be going into the detail of each one of them, what it does, what are the different modules in that, what are the different models and the variations available. Okay. 9000, 7000, 5000, 2000, these are the one. For the core layer, for the core layer, normally we do use the Nexus 9K devices. Why? This answer I'll give you in next half an hour. And why it is being required to use the Nexus 9K devices. So these are the series 9000, 7000, 5 and 2 for the core layer, which is nothing but the backbone, simple meaning. In order to send the data, we use the Nexus 9Ks. Okay. Because these are extremely high-end devices. Okay. Which are having, of course, the layer 2 and layer 3 capabilities. Okay. Now in this, if anyone has a prior experience or a prior knowledge to work on the Nexus devices, then they might be asking a question. Let's suppose Nexus 7K can also be used inside the core layer switches. And these are also both layer 2 and layer 3 capable, as same as Nexus 9K. Then what is the difference? Why we are going for Nexus 9K switches rather than 7K? First of all, new generation, also used as per your uh, cloud architecture with respect to the devices or the production, very high end devices. And the special feature which they are providing on top of everything is nothing but your 9K devices can be used for the ACI environment. For the ACI environment. Okay. All your other series, like your 7000, your 5000, and 2000, these are running on a certain operating system, and that particular operating system is known as NXOS. Okay. Nexus operating system. An operating system built for the future. But then some, now I'll not say all, but some of the models inside your 9K are running two operating system. And those are ACI and NXOS. Now understand, you cannot simultaneously run both the operating system in a single machine on a single chassis. That particular switch either has to run the ACI mode, either has to run into the NXOS mode. So these are nothing but the mode which I'm telling you. Running into the NXOS mode, then you'll be getting the switch capabilities. Okay, like your layer 3 routing, layer 2, other scenarios, your creation of the VPCs and the different topics out there which can be configured. But coming to the ACI mode, now the switch can be used for a ACI architecture, also sometimes called as like two-tier architecture, that ACI spine and leaf architecture, also being known as sometimes clause architecture. Okay. What are spine? What is a leaf? What are the work which they're gonna do? That will dedicatedly will be going through that ACI segment. In that I'll be discussing. So as of now, I'll not be discussing this particular thing, but this is the main difference why 9K is being used at the core layer maximum time in today's date, because it is capable of running an operating system and it is containing two different operating systems. You can change the mode to NXOS, you can change the mode to ACI. Now in this, you cannot expect to save the configuration into the Nexus mode and then again the rebooting the device into the ACI. Converting the mode will eventually reset the whole device, guys, first of all. So at one moment of the time, either it can be a ACI, either it can be a Nexus. And maximum time when you are switching at the core layer, so you use it for the ACI deployment. Okay, application centric infrastructure. Details for that will be going later on in the picture. Now, what else? So there are different variants. So let's talk about that. What are the different variants which are available inside your Nexus devices? Okay, different variants, different models, I would say. Okay, like Honda is a company, there are multiple cars inside Honda, right? Similarly, over here you have Nexus 9000 devices with these variant coming upon Nexus 9200, Nexus 9300, Nexus 9400. Yes. Then you have, sorry, my bad, Nexus 9500, You have the Nexus 9800 series. Okay, multiple series are available. And we'll be looking at what to use and where to use. Now, in this, the main thing is not all the devices or not all the variants are supporting the ACI. Don't get into that. Not all the variants are supporting the ACI. Some are ideally running on the NXOS operating system. Precisely, if I move 9500 and 9300 switches are having the capability to run either in the ACI mode or either in the NXOS mode. These are the two families. These are the two sub variants of the Nexus 9K, which has the capability to run the ACI mode as well. Okay. Now in the ACI mode, what happens actually? Why we are converting into the ACI mode? To basically to make it fully automated. To make it fully automated. If I use a normal term ACI, what is the meaning of ACI? Not the full form. What is the meaning? It's a SDN solution. Okay. To be precise, it's a Cisco's SDN solution. When Cisco want to become great into the software defined networking, and what do you mean by software defined networking? Can I write a very simple and cute word over here regarding automation? Can we say that, taking as a reference? Not the perfect answer, but it will relate. So doing the automated task, fully automation, policy based creation architecture, to design and manage all the data center fabrics, to manage multiple leaf from one single spine using a controller that is called as your APIC. For these kind of purposes, Cisco came up with a solution, and that solution was being running inside as a ACI mode into certain Nexus devices that are series are 9500 and the 9300. Okay. So today we'll be deeply and nicely we'll be discussing upon the 9500 series and the 9300 series. And then furthermore, we'll be taking the lecture ahead. Okay. Now, so taking into the consideration these two variants as of now, 9500 and 9300 series. These are called as your modular series switches. Whereas your 9300 is being termed as fixed switches. Okay. Now, what do you mean when you say, like, what is the difference between modular and fixed? What you can understand from this particular terminology? Anyone wants to explain or want to give any answer in the chat? Swappable with respect to sir. Others also, you guys can give the answer. No matter you are wrong or right, it doesn't matter. We all are starting from the scratch over here. Is having multiple line cards and supervisor card. Very good answer, sir. Swappable modules. Okay. Others, Naveen, you want to give any input on that? Surya, Usman, Vijay sir, what do you guys say? No input? That is also a good answer, sir. Model is scalable. Okay. Yeah, makes sense. Usman, good. So, pretty good answers we got. Now, see, we'll not answer this in a, what I can say is CCNA way. We'll be somehow giving the answer in a CCI way. Okay. So, modular switches allows you to expand. Okay, expand the modules. Now, what different modules are there that will come later into the picture, but it gives you a space to expand. It is just like that you have purchased a box. Okay, that can be any box, like a simple. I'll say that it can be an almirah, I would say. Okay, and all only at the bottom two drawers are being given, and this is completely being closed. And the vendor has told you that furthermore in life, if you require any more space, you can utilize this by breaking this board ahead, and you can place more racks into it, and you can scale it. Basically, you can use that particular space. Utilizing that space, now what we gonna put into D space, those are nothing but called as modules. As of now, I have not explained what are the different modules available. That will coming later into the picture. So modular series switches let you add the expansion modules inside the switches. Now this particular expansion module can be termed or can be explained in a different way that I'll be giving you. Okay. So what is the benefit for that? Scalability, of course. You are ordering a switch today from Cisco. You want that, okay, this is my current requirement. I don't want any other, this is my current data center requirement, and I'm okay with having these many ports or these many cards or these many engines, different things. And then after 2 years, if you want to scale it to a different certain extent, you can do that. But in fixed series switches, you cannot do anything. That is the major chunk. That is the major advantage of having the modular switch. But it comes with its own prices. Of course, prices will be high, right? They are giving so many things to you. So they'll be taking the huge amount of prices. And to be honest, uh, 9K series switches are not cheap. These are very expensive, high-end switches. Okay. Whatever the expense you can think in your mind, you can think it. It's a good hefty amount, I would say. Millions of dollars. Okay. Like uh, in India, we can say 50 lakh, 70 lakh, something like that. Or more than that if you want to become scalable. Whereas your fixed configuration switches, now these expansion modules are being later on used in order to get a connectivity with different networking devices. Okay, this will help you in order to get the connectivity for different networking devices. Those can be the firewalls, those can be the wireless connectivity, those can be multiple power supply unit, those can be multiple cooling fans. Okay, of course, if we are increasing the number of interfaces and if the switch is running on a very high stream, we obviously require the cooling fans as well, so that can be scalable as well. So flexible, but comes with a high capex. Capital is high. Whereas your fixed configuration or your fixed series switches provide a very fixed number of ports. Ports are fixed. Whatever the modules which are coming inside that are fixed. It's not, so I'll say, not expandable at all. Okay. Unmanaged switches, unmanaged. Smart switches, managed switches comes under the category of your fixed switches. Now, there is one more difference in that. Okay. One more point I'll add in on top of it. Whatever the expansion modules or the different modules which we are inserting into this series of switches 9500, okay, that can be segregated on the basis of your control plane, on the basis of your data plane, and the management plane, guys. This is also a very good point. Like I can have a dedicated module which is handling the control plane and the management plane of the device. I can have a dedicated module which can go along with the data plane of the device. So anytime now, anything happens to any one module, that can be removed, and that is nothing but hot swappable. Okay, you don't have to turn the complete device off in order to change any of the module. It's not like you have to turn off the whole switch, whole chassis, I would say, and then you move ahead with the changes or the manipulations inside the device, hardware level. No, you can change it anytime if something goes down. In the fixed configuration switches, you cannot do anything. In fixed configuration, all the three control plane, data plane, and the management plane are completely integrated within the device. Anything happens to any of the thing, the whole switch will get down. Something not working, it will not gonna work. Simple as that. Okay. These are also capable of making all the routing decisions, all the switching decisions, all the routing protocols which are being considered inside your control plane. Okay. For the data plane, we're gonna use the data management. Of course, the traffic movement. For that, we have multiple line cards which are available. Now, what is line cards? That I'll again give an explanation. Management plane, how you gonna manage that particular device. In modular, these can be divided into different modules. There are dedicated modules available, but for your fixed switches, no modules. Completely integrated in one shot. All three planes working together on the same device. Neither can be inserted, neither can be removed. Nothing can be inserted, nothing can be removed. Okay. Now, having said that, let's talk about your 9500 series switches first of all. Modular. Okay. Uh, are you are you able to hear any kind of noise from the background? Yes, no. Everything is clear, guys. Okay, cool, cool. Thank you, Vijay sir. Because as I think, I don't know if you guys know or not, but those who are living in India, today is a very big day. It's kind of a festive today in India. For the whole India, it's a big day today. And this is the actual time at 6:30 p.m. IST when we are starting the lecture. This is the main time that when that festive event has to happen. Okay, so whole Indian government into that. So that's the reason the temple opening, sir. You are right. Okay. So after probably 150 or 200 years of huge weightage, and now the temple is getting opened up. Yeah, 500. Sorry, my bad, sir. 500 years. So yeah, huge success. So sentiments are high in today's date with respect to Indians, I'll say. So everyone is enjoying out there. And we are having the lecture, enjoying here. Now, let's talk about the different modules. So first of all, module number 1. Supervisor module or soup module, you can say. There are different terminologies which are being used. It's the short form of supervisor, soup modules. Now, what is a soup module? What it actually does? So basically, soup module is nothing but it controls the control plane as well as the management plane. Supervisor module is responsible to control the control plane and the management plane. Okay. Second point, for Cisco 9500 series devices, there are half width supervisor modules which are available and which are inserted. Okay. Now, one more thing, these will be redundant. So that if one goes down, actually I have the another one to work on, right? Otherwise, if understand, if you are keeping a very small data center in-house, okay, or kind of working on a lab after expensive after you basically doing such expenses of having such high-end switches. So if you are having only one supervisor module and that goes down, so that means your control plane and your management plane is down. And without that, you'll not be able to do anything with the data, because this is nothing but your mind of your switch or the brain. It handles most of the things. Correct? Control plane is the brain of the device. So if that is being down, you'll not be able to do anything. So that's the reason always it is being best recommended. It's the best practice that you always have two supervisor module inside your device for the redundancy purposes. If one goes down, another one will still be have it. But one more point. These supervisor modules always work in your active standby mode. Okay. These are not working in the active. Remember that, guys. These are working in the active standby. Everyone over here aware of this particular terminology, active standby? Yes? No? Anyone wants an explanation on that? Yes? Others? All good? Clear, everyone? Active standby? No rocket science. So basically, out of two supervisor modules, when one goes down, then only other will become active. Simple as that. Standby will be having a standby mode. Only there will be certain type of connection which only gonna make sure that both the active and standby are actually um, getting to know each other, that they know that other one is still alive. Once the active become down, if in case, your standby eventually will become the active. Okay. More detail further will be going into that. So whichever one will become the active, so basically that one is the one which is being inserted first. Now understand. Okay. Out of two supervisor module, the one which you have inserted first will actually become the active one. Will actually become the active one. Simple. There is no extra rocket science which we have to implement in that. Okay. There is one external clock port which is being available, like for the NTP scenarios. It also support management through multiple interfaces, multiple ports. There are two USB port which are available. Okay. There are serial ports which are available on that supervisor module. Okay. There are 10 gig or 100 or one, sorry, not, I'll say gig, 10, 100 or 1000 Mbps port, Ethernet port, which are available on that supervisor module. And there is a rule of active standby. What is the rule says? Both devices has to be the same. Hardware has to be the same. Okay. So both the supervisor module which you are installing inside your 9K devices has to be the same model, which is being supported by that particular switch. That is also a main point. It's not like you can insert any supervisor module. Like suppose you come up with the supervisor module of 7K tomorrow and you are trying to insert it into your 9K device. It will not gonna work. Understand that. A certain series, a certain variants, a certain uh, modules are created. Only those can be inserted. Not everything can be done. So for that, obviously Cisco has given certain checklist or the data sheets to us. We can refer that. So that you have to refer at the time when you are trying to buy these kind of devices. Because supervisor module is something which you have to eventually insert it. And by that, let's suppose if I show you over here, okay, for Cisco 9500 series switches, images, I'll go into the images. So here are the supervisor module. You can see Nexus. Okay. Now, as you can see, sir, this is your half width. This is not a full width. This is not a full width device. This is a half width. See, this is your Cisco 9504 switch. Okay. And I hope this is pretty much bigger, as you can see completely. Now, in this, have a look. This is your supervisor module. Okay. Here it is being written soup 1, and soup number 2. Both are into active standby mode. What is these? Number 1, number 2, number 3, number 4. These are nothing but your 4 power supply units, PSUs. These are your power supply units. Okay. Fan unit, cooling unit will be seeing uh, at the back end. These are nothing but all the light, all the indicators, I would say. And now, what are these termed as? These are being termed as your line cards, sir. Okay. Simple, sober meaning. Components which can be modules which can be inserted inside an access device. Either it will be a power supply unit, either it will be a fan unit, either it will be the supervisor module, either it will be the line cards. Line card are nothing but your ports, your interfaces. Now these interfaces can be anything. It's not like it's mandatory that these interfaces will be only Ethernet. As you can see in row number 1, there are Ethernet interfaces, RJ45 interfaces. Okay, then you have the SFP interfaces. Okay, SFP modules has to be inserted using different segment of the cables. Then these are what? These are your QSFP ports. Okay, quad SFP. So if anyone, just a second, has not seen, I hope SFP module everyone has seen. Yes. So these are your SFP modules, sir. Okay, this is the backend. Okay, front will be a little bit different. So SFP modules are generally of, see, there are multiple. I'm not saying for 1 gig also SFP is available, for 10 gig also SFP is available, for dedicatedly for Nexus 2000 devices, which are a different segment, which has a different work to do. For that, there is a different model of the SFP which works. There are fiber SFP, which goes for 8 gig, which goes for 12 gig, 16 gig, just like that. There are Ethernet based modules, which are like 10 gig, okay, 100 gig, 1 gig. These are the different SFP modules which are available. Normally, you're going to see the 10 gig ports over there. Just a second. Okay. So normally you're going to see the 10 gig port, which you have seen over here inside the line cards. Now these 10 gig ports are available. And now let's suppose you have the 40 gig ports as well. 40 gig. That's the reason it is being called as quad SFP. 40 gig port. And now if you want to break this particular one port, okay, so you have inserted one line card of 40 gig and now you want to connect further mode. You have, see, understand, you have one 40 gig port. I want to connect this to 4 different switches or 4 different ports of another switch, which are having what? Which are having the SFP ports. For that, there is a kind of cable which comes out. That is called as your breakout cable. Okay, that is called as your breakout cable. And each cable which is breaking out, which is getting segregated out, will be having what? An SFP port ahead, each of 10 gig. So now I hope you can understand that how the propagation of the ports are being happening. So many 10 gig base ports you can connect from a 40 gig port. So many switches you can connect. And this is how actually a data center is being built. That's the reason 9K devices are staying at the core level, where they are able to generate or pass or propagate high amount of traffic. 40 gig, 400 gig ports are available nowadays. If you have seen the latest Cisco, I would say the event or something for the Nexus devices. Throughput value is going in TBPS, not in GBPS, but in TBPS. So if I also show you breakout cable. So this is what your breakout cable looks like, sir. Okay, this is how your breakout cable looks like. Now see, this one particular port which you are seeing is a quad SFP, 40 gig. Another 4 are 10 gig ports. Okay. And these are as well pretty expensive cables and very delicate. This blue color wire, which you are seeing, this is known as patch cord. Okay. Simple word, patch cord. Having the glass inside that, fiber optic wire, very thin, very thin, and very delicate. Also, this is not fixed. Let me tell you, it's not like you can. Uh, it's not if you are thinking that it cannot be detached, you are wrong. Basically, what this is what I mean to tell is, you can remove this particular cable from the port. You can detach it. It is detachable. Why I am focusing on this particular point? Because there is a kind of cable which is not detachable called as twin-X cable. Twin-X cable are nothing but your normal SFP cable. Okay. See, these are non-detachable. These are fixed. These are fixed port, which are being completely binded with the cable. Whereas your breakout cable is detachable. You can remove the quad SFP port and eventually you'll be able to remove the SFP also. So if any time you are thinking that your page code is gone, so it doesn't mean that you have to buy the complete set of cables. You can just simply remove the quad SFP module from the starting of the cable and you can attach a new one. Simple. That will work. Okay. Now, so now inside your 9500 series switches, okay, one module we have discussed is your supervisor module. After discussing the module only, then I'll be discussing the number of devices which are there inside this 9500 series. Okay. So first of all, supervisor module, which is being used to handle or manage the control plane or the data plane or the management plane. Sir, for twin-X cable, length varies. Okay. Like I have seen the twin-X cable of 1 meter also. I have seen 2 meters. I have seen 3 meters also. Okay. So normally in data center, 3 to 5, but there is a certain length which can be covered it out. It can go up to, I think, 20 or 40 meters of the length. It can go. Okay. Normally you'll see like 5 in normal data centers. You'll always see 4 to 5 meters. Okay. Page codes are not that long. Remember that. The patch cord which I'm talking about are not that long. They have a limited distance of like 5 to 7 meters. Okay. But this can go up to 10 meters as well, like for the twin-X cable, which is what I have seen. Okay, for the 10 gigabit cables. Now, 10 meter is the range. 10 meter you will find it out, not more than that. Vendors will not give it. Other than that, you will find 2, 5 is fine. Now, next segment. What else? So, as you have seen, now don't take it in a fixed manner that if you have seen the half width supervisor module, these are the only one which are present. There are full width supervisor modules as well, which you're gonna see further ahead. Okay, in the later section. Redundant supervisor are available and that has to be the same type inside the chassis. Okay. Half width slot, 2 are maximum which are available. Okay. Now, next is your, so this is point topic number 1 in which there are multiple things. Next module for which I have to change the ink is your what? System controller. System controller. Now, what is this? Supervisor module, you'll be able to see inside 9K also. You will be able to see inside 7K also, guys. System controller is not being there inside 7K. So I'll write not present inside 7K, first of all. Okay. Only present inside your 9K devices. Now, what is this? So basically, earlier what used to happen was this supervisor module, what I have told you. that it is handling the control plane and the management plane of the whole device. Apart from that, this supervisor module, as per the 7K series devices, these were also responsible to monitor what? The power supply unit. These were also responsible to monitor the heating issues, or yeah, basically the heating issues of the device, for the fan failures of the device. Okay. But now coming into the Cisco Nexus 9K, okay, when Cisco was actually designing the 9500 series, so they designed another module which is being called as a system controller, which eventually takes the responsibility, certain responsibility it carries out from your supervisor module. And now system controller is the one who is actually monitoring the fan, monitors the cooling, heating issues, whatever are there. Okay. Power supply unit related issues, PSU units. And it also monitors the internal communication, the internal communication between whom? Between two. Okay. Now see, is it a GUI? No, no, no. These are physical controllers, sir. Okay. Physical system controller. It was not present inside the 7K. So it monitors the fan. GUI is different. Okay. In GUI, you will be able to see these are not GUI based devices. Okay. When you go with the ACI also, if you are running the ACI, then you'll be able to see the GUI. And for that, you require a controller which is called as what? APIC. In NXOS mode, how you can manage with a GUI? What should be the answer? Anyone? How to manage a Nexus device with a GUI? Okay. So let me tell you that there is something called as, let me give you the answer over here. I don't know anyone heard about this. Okay. Nexus Dashboard Fabric Controller, called as DCNM. This is the GUI, okay, in which you actually integrate all of the Cisco Nexus based devices. But this is only being used whenever you want to quickly configure, whenever you have a, no problem, Manuel. Whenever you have a hybrid environment, whenever you want to have a extensive visibility on the complete environment for the automation perspective, okay, DCNM will allow you back to have certain automation tactics. DCNM will show you that what are the, so basically, if I may tell you that I earlier used to also be, coming back over here, I also used to be the instructor for Python automation, okay, inside your Cisco devices. So I've given lectures on that as well. Inside Python automation, if you know, one way to access the devices through API, okay, which isn't available in all the switches or the different routers in today's date. Whatever the new switches and the routers, like I'm talking about 5 to 7 years back also, whatever the Catalyst devices are there, those are capable of having the APIs through API. Apart from that, CLI is the one through which you can manage, like running the Python file inside the CLI. There in Nexus devices, you have the bash shell, which is being available. That I'll tell you later into the segment, how to join that bash shell, how to come out of it. Everything will be coming as per your lab scenarios. Okay. But have anyone heard about Ansible? Ansible. Abdul, Osman. Anyone heard about? Sushant sir, what do you say? Ansible, you have heard? Right. Right. So just like you have the Python, so it's a programming language. Similarly, Ansible is a orchestration tool. It's an automation tool. CLI based automation tool, which use certain libraries and all. Okay. So why I'm telling you is that, yeah, for the automation, absolutely correct. So with the DCNM, you are actually able to watch or see or edit all those particular libraries which are being installed inside your or hard coded inside your Nexus device. Basically, that is the GUI which is being present, and it's not individual. That GUI, that's an individual product, I would say. This is not which is something integrated inside your Nexus device. Completely independent GUI. You have to integrate. You have to join in a same network. You have to join your Nexus device with that particular DCNM GUI, and then you can manage that. Coming back, system controller is nothing but a physical controller which is being attached inside the device, which is monitoring the fan, cooling, PSU. So certain LED lights are there. Okay, so these kind of issues it will uh, not generate, it will take care of, and also it's gonna take care the internal communication between. Now understand what it is taking care of. For control plane and the management plane, you have something called as supervisor module. What you have for the data plane, guys? Just now we have seen. What do you have for the data plane? What do you use in order to transfer the data? If I may ask. Yeah, line cards, simple. So it also monitors the internal communication between these, between this supervisor module as well as the line cards. That is nothing but your system controller. Till now, everything is fine. All good, guys. Smooth. No problem at all. Chalo. Okay. Moving further ahead now. After the system controller, what you have? You have the line cards which are available. And line cards are nothing where your data plane resides, where your data plane comes into the picture. Okay. Line card means your port, your interfaces. There are multiple series of the line cards or the variants of the line card which you wanna see. Like in the 9500 C series line cards you wanna find. Okay. In 9400, sorry, not C series, 9500 series of line cards are available. 9400 series of line cards are available. 9700 series of line cards are available. There are multiple line cards which are available. If you want only 12 port line card, if you want only 16 port line card, you want them to be 10 gig or 40 gig or 100 gig or let's suppose 25 gig interfaces, you can have it. Multiple line cards. Okay. But again, dependency comes. These line cards will be as per your chassis only. Chassis is bigger, line card will be there as well. Okay. So there is a full width chassis. There will be full width line cards which will be there. Now question. Can I have a different series of line card on one particular single chassis? Is it possible? Can we have different series of line card on a single chassis? Yeah, it is possible. Okay. But there is a compatibility issue which needs to be checked. And for that, again, Cisco has given a very good data sheet availability in which you'll get the compatibility. But there can be different series of line cards which can be inserted into a particular chassis. And dedicated slots are there. Okay. It's not like in any of the slot you can insert the line card. It's not like that. Dedicated slots are there in which the line card will be inserted. Dedicated slots are there onto the chassis in which your supervisor module will be inserted. Cool. So this was a simple one. Next is your fabric modules. Okay. This is your fabric module. This comes from the rear end of the chassis. First point. You'll not see in the front of the Nexus 9500 series. You'll see at the rear end. And these all are placed vertically. So if you have a box, these are placed like this. Okay, supervisor module are placed like this. So these are nothing but front. Line cards are placed like this. This is also front. This is at the rear end, and these are placed vertically. These are your fabric model. Vertical placing, I would be saying. So first of all, let's see how a line card looks like. Oh, sorry, my bad. How a fabric module looks like. 9500 fabric modules having the pictures. Okay, what happened? Google Lens. So these are your, have a look, fabric modules. Up to 6 per chassis. These values I'll tell you that how many fabric modules are there. These are your fan trays. See what I said, fan trays will be at the back, right? So these are your fan trays. 1, 2, 3, 4. These are your fan trays. These are your system controller. Okay, Sushant sir, cool now? These are your system controller. These are being placed at the rear as well. And over here, these are your fabric modules. Up to 6 fabric modules can be placed inside this particular chassis. Over at the front, you have the line cards, you do have the supervisor modules, you do have the power supply units. Now, what is the work of that particular module? Okay. So what I written? Rear end of the chassis. Second, vertical placing is being done. Third, you can insert maximum 6 fabric modules. Okay. You have to insert maximum 6 fabric modules. No issue, Faizan. Okay. Minimum 3 are already inserted into the device when these are being given to you. Make sure minimum 3 fabric modules are already being given to you out of the box when you're gonna buy that particular switch. Because minimum 3 fabric modules are being required for the device to function properly, to make a decision, to be scalable. Okay, but maximum 6 fabric module you can send or you can insert. And every fabric module is being inserted or associated with certain bandwidth. Every fabric module is being inserted with certain fabric. Now let's understand what is the work. So let's say I have a fabric module over here. Okay. Bandwidth is what? What is the meaning of bandwidth? It's the amount of data that a module can handle at a particular time. Amount of data that a module can handle at a particular time. So now let's say my module, okay, the module which I have is capable of 100 gig. Understand, very clearly understand what is the work of fabric module. It is associated with certain bandwidth I have told you. Make sure this point, and now you understand the concept. So the module is capable of 100 gig. That this means that at any given moment of the time, my fabric module can handle up to 100 gig of traffic. From the front end, you are going to be inserting your line card. So I'll remove this. I'll remove this completely actually. See, this is my box. This is my front size. And this is my rear side, I'll say. On the front, I have placed the same box. These are your line card. Vertical placing of the fabric module. These are your fabric module. Line card are there for the ports. Fabric module is there for the bandwidth. Okay. But where do we get the bandwidth from? Port only, right? Port are the one which are handling the actual data plane or the traffic. So now understand that if one of the fabric module I have, which I'll just color it out with blue, red. This fabric module is of 100 gig. Okay. And the amount of traffic which is being handled from the line card. Okay. Now coming to the front end, let's take an example that I have inserted a line card of 12 port. Okay. Each of the interface of the line card, let's suppose it's a SFP port. What will be the speed? Normal interface, 10 gig, right? Total number of ports, 12. 12 into 10. What is the total value of throughput? 120. 120 gig. How much my fabric module is able to support? 100 gig. Will there be any issue? Yes or no? What do you say? Obviously, right? The capability of the fabric module is to handle the bandwidth of 100 gig max because I have placed only one as of now, which I have scratched into the red. The amount of ports are 12 on a line card. Let's suppose line card number 1, this one. These have 12 ports. Each port is of 10 gig. 12 into 10, 120 gig total bandwidth, which the line card is sending. Let's suppose this particular line card is running on its huge capacity, full capacity. 120 gig of traffic will not be able to handle by your fabric module. At that particular moment, you will understand that, okay, you will call to Cisco. Yeah, there will be latency issues, sir. There will be drops. And at that time, you're going to call to Cisco and ask them, kindly, please, can I have one more fabric module? Is it available? Now you inserted one more fabric module. Number two, what is the total bandwidth? 200 gig. What is the total throughput? 120. Easily able to handle. No latency, no traffic drops, nothing. Okay. So this is how you'll get to know that what are the resources, the hardware resources which you are having inside your Nexus switch are low and how you're gonna scale them based on these parameters. You have to do certain calculations on top of that. Okay. Now, apart from that, your fabric module does one more thing. It also take care of the line card to line card communication. When I say earlier, we talked about what? System controller. That system controller was the one who gonna be taking care of the communication happening between your line card and the supervisor module, basically your control plane as well as the data plane. But the fabric module is having the communication or is responsible to maintain the communication between line card to line card. Okay, basically the intra data plane communication. But if in case we have a device number A connected to port number 1 of the line card and we have another device switch number B or something connected to the second port. So this internal switching will also be taken care of by the fabric module. It also gonna take care of the internal switching which will be happening. Okay. And these are the parameters which you need to take care of while purchasing a new fabric module. And now in this, understand, all the fabric modules will be completely active. There is no concept of active standby. Like in your supervisor module, there was a concept of active standby, right? Over here in fabric module, these will be active, active. All will be active. That is the reason we got a total throughput of 200 gig, right? No latency, no drops, nothing. Okay. Now, in a nutshell, before moving ahead, what are the different devices? Let's discuss that inside your 9500 series. So, in your 9500, you have three models available that are 9504, that are 9508 and that are over here. I'm going to write 9516. What is 95? First two digit always represent the series 95. Last two digits always represent the number of line cards which it can support. So 950 can support up to 4 line cards. 9516 can support up to, I'll say up to 16 line cards, and this will support up to 8 line cards. This is gonna have up to 4 power supply unit. Okay. This is gonna have up to 6 fabric module that I also showed you inside that pic. It was being written over there. It's gonna support up to 6 fabric module, all of the same type. You cannot change the type of the fabric module which is being supported. It has to be the same fabric module. It can support up to 2 system controllers. That also we have seen inside your 9504. Bare minimum. Maximum 2, it gonna support up to 2. Up to 2 supervisor module and up to 3 fan trays. Okay. Now understand. Rest of these configuration, rest of this system compute resources will be same with respect to 9516, will be same with respect to your 9508 as well. Same 3 fan trays, supervisor module 2, maximum you can have 2 system controller, 6 fabric module of the same type. You can have inside all the 3 switches your 16, 8 and 4. Okay. Clear everyone over here? Till now, all good? Anything which you didn't got it out of these modules? I hope it is clear. I have shown you as per the pictures also. So it will be more clearer inside your hardware devices. Faizan, Abdul, Sushant, Osman. Clear? Wonderful, sir. So that was all, I think, for today. Tomorrow, now we'll be having the discussion because there are huge amount of devices which are available inside your 9300, and there are more details into that. So that will be coming later on tomorrow's in the picture. And tomorrow we'll be also discussing the 7K devices. So we'll be going into the ascending order starting from the 9Ks, then 7Ks, then 5Ks, and then 2Ks. Clear? Great.
Sir, I missed a little bit. Will you be posting a recording soon?
Yeah. Arey, sir, just now,
Okay.
after the lecture only, I'll put
Okay.
it up. Okay?
Okay,
No
thank you.
problem. Yeah, Abdul sir, you require the syllabus. So syllabus,
Yes, syllabus.
syllabus was, I think earlier was being posted over the website only. I'll send the link into the WhatsApp group. You can have a look from there. Okay.
Okay, so the docs
Yeah.
will be on the website.
Yeah, the docs will be on the docs related to your syllabus part. Apart from that, whatever the references will be there that I'll be covering. So for that references, I'll be sharing directly you into the classroom. Okay. Whatever will be there, including your lab modules and the lab availabilities. Okay. What will be the timing of the course? So, sir, initially, I think almost 10 to 12 days I require for the Nexus to be finished. And after that, same amount of devices, 15, I'll be taking for the ACI. I have to include the multicast as well, which is going to take certain days, like 2 to 3 days.
So how about the duration?
Probably 1 month, you can say.
1 month. The Nexus and the ACI.
Yeah, Nexus and the ACI, including the multicast in that. Yes. Yeah, sir, timing will be same as you are going through, like Monday to Friday, 6:30 p.m. IST. That's all. Okay, clear and cut so that you guys can enjoy your weekend. I can enjoy my weekend as well. No problem from both sides. Okay, all
Okay.
good. Perfect.
Okay,
So
thank you. Bye.
wonderful. With that, let's end for the day, guys. We'll meet tomorrow, same time. Till then, take care. See ya. Bye bye. Have a great day.
Yeah.